Hello. The purpose of this video is to go over a couple of applications typical application that we find when we are dealing with rational expressions and equations. The first type of application I'm going to go over is the quote-unquote work problems. And this is the typical example. Sorry, it's a little bit tight here. It takes Becky 3 hours to clean the barn. It takes John 4 hours to do the same task. Working together, how long would it take? Okay, so Becky alone, in order for her to complete the task, it takes her 3 hours. John takes 4 hours. Working together, how long? Obviously, working together has to be less than 3. Otherwise, what did Becky want John's help if it's going to be more than 3, right? So I know that the top would be 3, which is unrealistic because of course John has to be able to help. So this is the approach I like to do. So let me just use B for Becky, John, and working together, okay? I just use T. Okay. Becky, John, together. How many hours? Of course, Becky takes 3 hours. John takes 4 hours. Working together, of course, this is the unknown. I'm going to use T as in T hours. In 1 hour, what percent of the task each person completes will be able to achieve? Of course, if Becky takes 3 hours, in 1 hour, she can complete a third of the job. Likewise, if John takes 4 hours, in 1 hour, he can complete 1/4 of the job. So Becky 3 hours, therefore in an hour, 1/3 of the work. John 4 hours, therefore in 1 hour, 1/4 of the work. Working together, it will take them T hours, therefore in 1 hour, they will do 1/T of the work. And notice, of course, working together, meaning that Becky's contribution plus John's contribution has to be equals to 1/T. In other words, 1/3 plus 1/4 must be equal to 1/T. And how do I solve this? This is, of course, an equation, a rational equation. Obviously, we always multiply by the LCD on the left. 3, 4T, that will be 3 times 4, 12T over 1. And I multiply here, of course, 12T over 1. Notice that when we distribute 12T over 3, 12 divided by 3 will be 4 times T plus. Likewise, when I distribute this, 12 divided by 4 would be 3. So plus 3T equals T over T is 1, so it will be equals to 4. Of course, last time we checked 3 plus 4 equals 7T equals 12. So with 4T, of course, we divide by 7. We divide by 7. And what do I get? T equals 12 over 7, which should be in mixed fraction, 1 hour. And 12 minus 7 will be 5/7. So it will be 1 hour, 1 and 5/7 hour. If I want to convert these to minutes, of course, we know that we have 60 minutes in 1 hour. So this is what we are going to do. Just take 5/7 and multiply by 60 to see what you get. And that will be the number of minutes that it will take. Of course, if you do 5 times 60, well, 5 times 6, that's 300. 300 divided by 7, I think that's about 42.8. So it's approximately 43. So working together, these two fellows, it will take them 1 hour and just about 43 minutes to clean the barn. So Becky takes 3 hours on her own. John takes 4 hours on his own. Working together, it would take them less than 2 hours, 1 hour and 43 minutes. Okay, let's try another one. Let's try another example. Okay, I have this one. But this pool, the Harrow's pool, can be filled in 20 hours using their spring alone, and in 15 hours using their well alone. How long will it take to fill the pool if both the spring and the well are used at the same time? So I'm going to write the information and then I will stop sharing. So if I use the spring alone, it will take 20 hours. If I use the well alone, it will take 15 hours. Together, that's the question, how long, okay? 2015, perfect. So I'm going to use S for the spring and W for the well alone. Let me stop sharing here. So let's see what we have. Okay. Well, just like we did before, let's go ahead and normalize it in per hour. So if it takes a total of 20 hours, of course, 1/20 worth of the work will be done in 1 hour. Likewise, if the well takes 15 hours, 1/15 of the work in 1 hour. Working together, let's call it, of course, lowercase t, that'll be 1/t. So my equation will be working together equals this, 1/20 plus 1/15 equals 1/t. What is the LCD between 20 and 15? So we can count 20 at a time, 20, 40, 60, 80, 100, 15 at a time, 15, 30, 45, 60, 75, ta, 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 ta. So notice that the first number that we encounter is 60. Let's do that again. 20, 40, 60, 80, blah, blah, blah. 15, 45, I'm sorry, 15, I really wanted to get to 60 quick. 15, 30, 45, 60, 75, ta, ta, ta. Notice that the first number that repeats is 60. So in this 60 is my LCD. 60T. So if I multiply by, I'm going to do it this time differently. 60T times this, 60T times, sorry about that. 60T times 1 and then 60T. Let's see what we get. 60 divided by 20, that would be 3 times T times 1, 3T. 60 divided by 15, that would be 4 times T times 1 plus 4T equals, what do I have here? T/T will be 60. So we have it here, 3 plus 4, 7T equals 60. So we divide by 7, T equals 60/7. Now, what do I do with this 6/7? Well, let's go ahead and practice long division. So 60 T, 7 fits into 60. What? 8 times that will be 56. Remainder 4. So this is the same thing as what? As 8 hours and 4/7. Okay. Now, if I take 4/7 and I multiply times 60. Why 60? 60 minutes in 1 hour. This will be approximately 34 point something. So what can we conclude? That these two sources of water to fill in the pool would be 8 hours and 34 minutes. 8 hours, 34 minutes. Yeah. So this improper fraction, to the long division to see what is the quotient and the remainder. So it will be 8 hours and 4/7. And then we can take 4/7 and convert it to minutes by multiplying by 60 minutes in 1 hour. 4 times 60, 240 divided by 7, that's 34.2 or something. So 8 hours and 34 minutes. Let's try a second type of word problems. In this case, we're going to try proportion. Recall that what is a proportion? A fraction equals to a fraction. A/B equals C/D. Fraction equals a fraction. It's called a proportion. And if you recall, as long as I have a fraction and a fractions, we can always cross multiply. So what can we conclude? That A times D equals BC. So we can always cross multiply. So let's try the first one. Hopefully you can read this one. A baseball player gets 8 hits in 12 games. At this rate, how many hits he will get in 162 games? I'm going to write the information in the lyric board, and then I'm going to stop sharing the screen. So the important thing is just to be consistent about how we set up the proportion. Notice that we have hits and we have games. So it doesn't matter how you set it up, as long as you're consistent. What I'm going to do, I'm going to place the hits in the numerator and games in the denominator. So what do I have? This baseball player can hit 4 hits in 12 games. At this rate, how many hits? Of course, I need to find hits when he plays 162 games. So let me stop sharing the screen. And this is what we have. I'm going to use hits over game. So 4 hits in 12 games, how many hits in 162 games? So this will be the unknown X. Notice that I can just quickly cross multiply. However, I'm not going to do that yet, because notice that 4 over 12 can be simplified. I can reduce it by 4. So remember that this is 4 over 4, that's 1. 12 over 4, that's 1/3. So my new proportion is 1/3 equals X over 162. Cross multiply, 3 times X equals 3X equals 1 times 162. 162 divided by 3 divided by 3. X equals, I should have done that first, X equals 162 divided by 3. Using a simple calculator, that gives me 54. 54 what? Remember, 54 hits. So the answer will be 54 hits. It's as simple as that. Settle the proportion, cross multiply, and solve accordingly. Let's try another example. Let's try another example of proportion. So what about if we have the following? To estimate the number of deer in a game preserve, a scientist catches and tags 18 deer and releases them. Later, 30 deer are caught, 4 of them are tagged. How many deer are in the preserve? Okay, so what we have here is we are comparing two variables. So we have the tagged deer versus the normal or total deer, right? Population. So notice that the scientist, out of the sample that he takes, he collects 30 deer. Out of those 30, 4 are tagged. So that's, we know, this is the proportion, this is the ratio between the subset that we caught, 30 deer, out of those 34 were tagged. Now, if I want to know how many total population we have if we tag 18. So this is what we have. Let me stop sharing this. So this will be my population. So I'm going to place tag as the numerator, the population the denominator. So out of a subset of population, 34 were tagged. If I catch 18 that were tagged, how many we have in total? So once again, this is the unknown. This is my total population. So cross multiply. However, notice that 4 over 30 can be simplified. Both numbers are even. So I can simplify by 2. This is the same thing as 2 over 15. Right? I divide it to 2. So we have 2 over 15 equals 18 over x. Cross multiply, 2 times x, 2x equals 15 times 18. So we by x, we divide by 2. And this is what we have. We have x equal 18 times 15 divided by 2. Now, just to keep it simple, notice that 18 divided by 2 is 9. So the actual number would be 15 times 9. 15, 18 divided by 2, that would be 9. And that would be 135. Let's see, 15 times 9, 135. So this is, of course, equals to 135. And this is how many deer in the preserve we have. 135 deer. So repeat settle the two proportions, 4/30 equals 18 over the unknown. Just to keep it simple, 4/30 can be simplified at 2/15, cross multiply, 2 times 6 equals 15 times 18. Now we divide by 2. Before we multiply 15 times 18 divided by 2, which is 135. If we want to work a little bit smarter, we can just simplify 18 divided by 2, which is 9. 9 times 15, 135. And we will be done. Let's try the last two applications we're going to discuss. It's variation. Within the variation, we're going to study two types of variation: direct variation and inverse variation. The keywords will be as follows: direct variation, y varies directly as x. You might read also y is directly proportional to x. You should read proportional. This is bad. Proportional. Y is directly proportional to x. And what is the formula? Y equals k times x. If you read direct variation, how do you know it's direct variation? One of these two phrases will show up. Y varies directly as x, or y is directly proportional to x. What's the formula? Y equals kx. Similarly, you might hear inverse variation. How do we know it's an inverse variation? You will hear the following: y varies inversely as x, or you can also read y is inversely proportional to x. Y is inversely proportional to x. And the formula will be y equals k over x. Recall, direct variation y equals kx. Inverse variation will be y equals k over x. As you will notice, direct variation is proportional. And then inverse variation, of course, is k over x. So let's try two examples of each, and we'll wrap up this one. So let's start our first example of direct variation. First of all, let's recall the definition, of course. If it's direct variation, y equals kx. The first example, find the variation constant and the equation of variation in which y varies directly as x. So this is it. Once they tell us that y varies directly as x, we already know that what? Y equals kx, because it varies directly. So y is 3 when x is 8. Okay, so we know that y equals kx, the direct variation, and the numbers were y is 3 when x is 8. Okay, no big deal. So let's see what we do here. Y is 3 when x is 8. So we have y equals k times 8. We substitute y for 3, x for 8. How much is k? Well, no big deal. We divide it by 8. We divide by 8. Therefore, k, which is the constant variation, will be 3 over 8. And what is my equation? Y equals, how much was k? 3 over 8 times x, and that will be it. So we have the constant variation and the equation itself. Let's go ahead and do a second example. The amount of simple interest I receive on the savings account varies directly as the amount of money. So in this case, the I, remember y varies directly as x. So y will be, in this case, my I varies what? Directly as the amount of money M. So what I equals k times M. The interest varies directly or is directly proportional to the money M. So then it says, I'm going to share. Then we said, if $250 to the money $520 earn, which is the interest, $10.40. Okay, so let's see what we have. So now they tell us, okay, we know that interest is K times M. If $520 earn $10.40 in interest, how much is K? Well, we just simply divide by 520, and K equals, I need my calculator. So that would be 10.4 divided by 520, 0.02. 0.02% interest. So what is my equation? So therefore, the interest is going to be 0.02 times the amount of money that we deposit. Now, they ask us how much interest we're going to make if we deposit $650. So when M, the deposit equals 650, I would be 0.02 times 650. So we just have to find the 2% of 650. Sorry about that. 50 times 0.02. That would be, of course, $13. So we will make $13 in interest. So let's recap. We need to find out the equation. Once we find the equation, we use the information they gave us. They always have to give us one quote-unquote pair of numbers for M and for I, because remember we have three variables. In this case, I, K, and N. They have to give us I and M so we can solve for K. Once we solve for K, we can come up with the equation, the general equation. And with that, then, if they give us M, we solve for I, they give us I, we solve for M. And that will be it. Okay, so that's the two applications of direct variation. Let's go ahead and look inverse variation. So let's go ahead and do two examples of inverse variation. Just a quick recall, inverse variation y equals K over X. Let's go ahead and do two examples. That's my Word file. So, okay, so inverse variation, the keywords is y is inversely proportional to X, or y varies inversely as X. So the form will be y equals K over X. Okay, look at the first example. We know that y varies inversely as X. Of course, we need to use the formula y equals K over X. And they give us one set of numbers. They say that y is 75 when X is 0.1. So what's the only thing we need to do? First, we need to solve for K, and then we come up with the equation. So this one is very difficult. So we remember 75 over 1. So we cross multiply K times 1 equals K, equals 75 times 0.1. We just move the point, so it will be 7.5. So, and then the equation will be y equals, how much was K? 7.5 over X. And this is my equation. Opa. And this is, of course, K. And that would be it. 7.5 over X. Let's go ahead and do one more problem. And that would be it. Let's go ahead and do the word problem. The number of workers required to paint a house is inversely proportional to the time spent working. Okay, so let's stop there. So the number of workers, W, is inversely proportional to the what? To the time working. So I can say that W, if it represents workers, is inversely proportional, or varies inversely as, in this case they use the word inversely proportional to the time. So W equals K over T. So we know that it takes 15 hours for 2 people and then 6 hours. Okay, so let me stop sharing the screen. So this is what we have. Workers equals K over T. So we need to look for the information they give us. So what do we know? We know that it takes 15 hours. So of course, hours will be time when we have 2 workers working. 2 over 1, cross multiply, 1 times K is K, 2 times 15 will be 30. So K equals 2 times 15, which is of course 30. So what is my formula? W equals K, that we just found, 30 over T. Now that we have the formula, the question they ask us, what about how many workers do we need for 6 hours? So when T equals 6 hours, comma, workers equals 30 divided by 6. And of course, last time we checked, 30 divided by 6 equals 5. 5 what? 5 workers. That would be it. Let me share the document once again. So what can we conclude? How many workers are needed to paint the house in 6 hours? For 6 hours, we need what? 5 workers, and that would be it. So in summary, we went over 3 types of work problems. Number 1, work-related problems. Number 2, proportions. And number 3, variation. Within variation, we have 2 flavors, inverse variation and direct variation. Thank you.